In this video, we're going to be solving quadratics by completing the square. So let's look at this example. X squared plus 2x minus 6 equals 0. Now, what I want to do is I want to simplify this problem to just x squared plus 2x. Okay, let's just ignore the rest of the problem. Let's even ignore the equal sign for now. Now, my question is, how can I factor this as a perfect square trinomial? Now, a perfect square trinomial is, of course, a trinomial. So I'm missing a term here. Okay, there's a third term, and that third term is something that would make this a perfect square trinomial. So let's just think about this. If this was x plus or minus something squared. So what would that third term have to be so that I would get a middle term of 2x? Now, let's break this down a little bit further. Let's expand this. So I know that the first term in each one of my factors is going to be x and x. I don't know what the last term in each one of my factors is going to be because I don't know what the last term of the trinomial is. But I do know that when I go to check my outers and inners, I need to get a sum that is 2x. And in a perfect square trinomial, my outers and my inners are going to be the same thing. So in order to get 2x as a sum, this has to be 1x, my outers have to add up to 1x, and my inners have to add up to 1x. So for that to be true, the last factors in each one of my binomials has to be positive 1 and positive 1. So now I can use those two factors to find what my last term is going to be. If I just multiply 1 times 1 together, I'm going to get my last term to be positive 1. So if my last term was positive 1, then this would be a perfect square trinomial, and I could factor it as x plus 1 squared. So why did I just go through all of that? Well, when we're solving these quadratics by completing the square, the goal is to rewrite one side as a binomial squared so I can take a square root. Excuse me. So let's just go ahead and we're going to try to solve this now. So we have x squared plus 2x minus 6 equals 0. Now the first step to solving this by completing the square, we can add 6 to both sides. And we're left with x squared plus 2x equals 6. Now, we do that because we can now ignore the 6. It's on the right side of the equation. Excuse me. So now we're basically going to go through the same process that I just went through. I know that if I add 1 to the left side, I can factor this as x plus 1 squared. And then I can take the square root of that, and I'll be left with x plus 1. So I just added 1 on the left side, which means I need to add 1 on the right side, which would give me 7, which then, if I'm taking the square root of both sides in my next step, I will have plus or minus the square root of 7. And now I can just subtract 1 on both sides to get x alone. So my answer is negative 1 plus or minus radical 7. Now the question is, how can I go through this and complete the square easier than going through this process I did on the left? So in order to get that plus 1 that I ended up adding to both sides, what we can do is take that middle term and divide that middle term by 2 and then square that. If you take that middle term divided by 2 and square it, that will be the number that you add to both sides. So in this case, the middle term is 2. If you take 2, divide 2 by 2, and square it, you get 1 squared, which is 1, which is the number I added to both sides. Now, why does that work? Well, if we look back to my work on the left side, that middle term, when we're dividing it by 2, that is splitting that middle term up between, like amongst the outers and the inners. So that's where that portion of it comes into play. Now, why do we square it? Well, we square it because that is this final step of multiplying your last terms together in your FOIL process. So take your middle term divided by 2 and square it, and you'll be able to complete the square. So let's see if we can do that in the next problem. Okay, we have B. 2x squared plus 8x plus 3. Now, I'm going to start off by subtracting 3 on both sides. We have 2x squared plus 8x equals negative 3. Now, notice we have a coefficient of 2 on our quadratic term. That is a problem because we cannot have a coefficient of 2 for our trinomial to be a perfect square trinomial. 2 is not a perfect square. So what we're going to do to make our life a little bit easier is we are going to divide both sides by 2, which divides every single term by 2. So the result is x squared plus 4x equals negative 3/2. A little ugly on the right side, but that's okay. Now we're going to complete the square. Remember, to complete the square, we're going to take that middle term, we're going to divide it by 2, and square it, and that's the number we're going to add to both sides. Take the middle term, divide it by 2, and square it. And now, on the left, if we want to do this, we can. We will rewrite this as x squared plus 4x plus 4. And on the right side, so this ends up being negative 3/2 plus 4. Now, we're going to factor the left side. We already know how to factor this. Okay, this is just going to be x plus 2 quantity squared. How do we know how to factor that? Well, when we complete the square, see this 4 divided by 2? 4 divided by 2 is 2. That is what goes inside our factors. Now on the right side, we have negative 3/2 plus 4. So if you want to, you can kind of like go ahead and think about this. Okay, 4, we need common denominators. 4's we could rewrite as 8 divided by 2. This is negative 3 over 2 plus 8 over 2, which is 5 over 2. Now we have the left side is something squared, so we could take the square root of both sides. With x plus 2 equals positive or negative square root of 5 over 2. And then, I'm going to have to rewrite it over here. I'm just going to, let's rewrite it. X plus 2 equals positive or negative 5/2. I'm going to subtract 2 on both sides. We have x equals negative 2 plus or minus square root of 5 over 2. So this is our answer. This is not our answer simplified, but it's our answer. So I'm going to simplify this. So we have square root of 5 over 2. That could be rewritten as square root of 5 over square root of 2. And we're going to rationalize the denominator. So if we just multiply the numerator and denominator by radical 2, we end up with negative 2 plus or minus the square root of 10 over 2. And now that's our answer, rationalized and simplified. And we have one more example. One more example that's going to get quite interesting. Okay? So, we go through the process as we have. We add 5 to both sides. We're left with 3x squared minus 4x equals 5. We have a coefficient of 3. We want a coefficient of 1. So we divide the entire equation, every term, by 3, and we end up with x squared minus 4/3 x equals 5/3. Now, I will be honest. If this is the problem given to you, you're asked to solve this quadratic. I, personally, would not solve this by completing the square. I would solve this using the quadratic formula, which we will look at in the next video. How do you know when to complete the square and when not to complete the square? Well, if you look at these other examples, okay, the easiest one to complete the square was this first one. We have a coefficient of 1, and our middle term was even. This second one, we could complete the square. We did that pretty successfully. The middle term, again, was even. I shouldn't actually highlight it there. The middle term after we got rid of the coefficient of 2 was even. Right there. Okay, completing the square is still, relatively easy. Here, in this case, we have a coefficient of x squared that's not 1, and once we get rid of that coefficient of 3, our middle term is quite hideous. It's not only not even, it's a fraction. So now the next step, you're going to see why this is not the method of choice. The next step is to take that middle term of 4/3, divide it by 2, and square it. And that's what we're going to add to both sides. Take 4/3, divide it by 2, and square it. So x squared minus 4/3 x. So 4/3 divided by 2 ends up being 4/6 squared. So this, for the record, can be simplified as 2/3. So that's going to be 2/3 squared, which is 4/9. We'd end up factoring that as x minus 2/3 squared. The right side is, let's see. So this ends up being 2/3 squared, which is 4/9. And then we have to add these two fractions together. So this ends up being, if we multiply this times 3 and this times 3, so that's 15 plus 4 is 19/9. And you can see, again, why this is not the method of choice. Okay, you can drown in the arithmetic. So this is plus or minus square root of 19 over 9. Well, 9 is a perfect square, so the denominator is 3. We have square root of 19 in the numerator. And then we're going to add 2/3 to both sides. And we have x is equal to 2/3 plus or minus square root of 19 over 3, which we could either write that as our answer, or because we have common denominators, we could write that as 2 plus or minus square root of 19 over 3. And if you're super brave, you could take that, plug both of those answers into the equation above, and check them. I will leave that